So the second part of this review is about integration. You still have one question on differential, but probably I will skip this question for you, so you will not have this problem on the final exam. So let's talk about integration. Okay. Actually, we wrote a test today. I hope you know. I hope you do well. We will see that when I create. So the first problem in integration is 11. Is 11. Find the definite integral. 11. Yes, this problem is very similar to the first integral today. So what should we do with this? With these guys, you know, we have rational. On the top we x squared minus a. In the bottom we have ax. But we know only we know how to take integrals of power function. So probably we can convert those functions into power. And I divide x squared by ax and 8 by 8 over x. I have the following: x squared over ax minus 8 over ax dx. You see? And what is this? That's noting 1 over 8 integral of x squared over x means just x, right? Just x dx. 1 over 8 x dx. The second one, a with a will be cancelled out. But I have negative in here. So negative dx over x. That's it. And here I have 1, 8 x squared over 2 because the power here is 1. But here we cannot apply the power rule. Integral of dx over x is ln of absolute x plus c. So that's what we have. Almost we have today. The second problem. That is problem 5. Find a particular solution of the following differential equation: f derivative x equal to 12x minus 4x cubed, and the initial condition is f3 equal to 5. Again, that's what we have today on the test. But the function is simpler because we have linear function. So we need to recover. We need to recover the function. F derivative. We have f derivative. In order to recover f, we need to take integral. Integral of 12x minus 4x cubed dx, right? And then we have what? This just power function 12x squared over 2 minus 4x4 over 4 plus c. Don't forget about c. Right? So let's simplify that. I have 6x squared. 4 and 4 simplify. I have x to 4 and plus c. That is our function. And we need to recover the full function. We need to use the initial condition f3 equal to 5 in order to find c. So what does it mean? That means I need to plug 3 into the function and set everything equal to 5, right? Since f3 equal to 5, from here I get 6, 3 squared minus 3 to 4 plus c equal to 5. We simplify that, you get what? Here you get x3, here you have 9, 9 means I have 3 times 3 squared means negative 27. So I have negative 27 plus c equal to 5, or c is 5 plus 27, which is 32. And then I just substitute c by 32, I get the function. That is the problem 5. Okay, next problem. Determine the area of the given region. Here the function y equal to x plus sine of x. And even here we are given the function, and this is the region, interval from 0 to pi. So for this problem, we are good because we know exactly the area of this region is positive because the function is above x86. The only thing we need to do is evaluate integral from 0 to pi, right, of this function. So the area is equal to integral from 0 to pi x plus psi of x dx, which is 1 over 2x squared. The integral of psi is negative psi, is negative cosine, right? Evaluate from 0 to pi. So how to evaluate this? You plug pi into this function. That's 1 over 2 pi squared minus cosine of pi. And then minus, use parentheses please. So 0 in here, I have 1 over 2, 0 minus cosine of 0. Cosine of pi is negative 1, right? Cosine of pi is negative 1. So I have negative 1 over 2 pi squared minus negative 1. This is 0, cosine of 0 is 1, negative with negative plus 1. So overall, I have 1 over 2 pi squared plus 2. But our problem today in the test was, I remember x minus x to 7, and you consider interval 0 to 1. Some of you did not graph the function, and I mentioned several times, when you have a function, you have to make sure that the graph is under or above. Make sense? Is above or under? Because we might have positive, we might have a mix. Some part of the graph is under, some part of the graph is above. So we have to make sure the graph of this function is above x-axis, and then you take integral. But some of you forgot about it. All right, let's finish this problem and move to the next. Next question. Let's say this question has several parts, but again, the only thing you need to do on the final exam is evaluate definite integral, and that integral looks like integral from -1 to 0, t 1/3 minus t 2/3, right? dt. So power rule. The first integral is t 1/3 plus 1 over 1/3 plus 1, and then the second one is t 2/3 plus 1 over 2/3 plus 1, and then evaluate from -1 to 0. That's it. Why? You can use calculator to find it. At 0, everything is 0. At -1, you just plug -1 into this. But don't forget to use parentheses. So you would get 0 minus -1, 4/3 over 4/3, use parentheses, minus -1, 5/3 over 5/3. Okay, use that, please. I mean, I can simplify that, but please do that for yourself. Just practice a little. And then the next question is evaluate, question 2, 3/6, 1 over 3x plus 7 dx. But we did not cover this topic, how to change the interval or integral limits when we do substitution, but I can show you how to do that right now, right? So in this integral, we need to do substitution. We put u equal to 3x plus 7. So we put u equal to 3x plus 7. And we find right away du equal to 3 dx. That's the first thing. Second thing, since we have definite integrals, we need to change the integral limits. How to change that? We need to change that first. Why? Because we go from x to u, right? So once we change from x to u, we need to change interval here. So based on this substitution, when x equal to 3, I would write u equal to 3 times 3 plus 7, which is 16. I just use this substitution, right? And when x equal to 6, I again use this substitution. If I u equal to 6 times 3 plus 7, here is 18 plus this, I have 25. You see? So, I have the following one. From this guy, I have dx equal to du over 3, right? Now I rewrite the original integral. The integral will not be from 3 to 6, but from 16 to 25, because now we integrate with respect to new variable. We already changed from x to u, right? So that's why we have to use new integral limits. What is dx? Dx is du over 3. And here we have 1 over square root of u. Done? And of course not almost done. So let's say 16 over 25 and then du. What is square root of u? Square root of u is u to 1/2. And then I flip that, I get u negative 1 over 2 du. Right? And you use power rule to evaluate this guy. And this guy is u negative 1 over 2 plus 1 over negative 1 over 2 plus 1, evaluate from 16 to 25. And you get his square root of u is 1 over 2. You flip that, you get 2 times square root of 25 minus square root of 16. And here's 5, 4, you get 2. That's how we can change integral limits when we do substitution. Okay, finally, indefinite integrals, right? With substitution. 3 plus 9 over t cubed 9 over t squared dt. Yeah, today we also have that problem. So you see, the best ways to choose substitution is look at the function under integral, and we see what kind of function is composite. And we choose the inside function to do substitution. So this guy is composite because x plus 9 over t cubed, right? So I will choose the inside, I put u equal to 3 plus 9 over t. I will do that. And then I take derivative. I have du, derivative of 3 is 0. Derivative of this guy is negative 9 dt over t squared. You see, I already have 9 dt over t squared here. That's perfect. So that means 9 dt t squared equal to negative du. And now I can rewrite our integral. That is u cubed times negative du, or which is negative u cubed du, and that is negative u to 4 over 4 plus c. And then at the end, I have to substitute 3 plus 9 over t back here, right? Because we need the answer in t. So the final answer is negative 3 plus 9 over t to 4 plus c. Yeah, so I think that is all about the final, about the practice final exam. So enjoy videos, practice yourself, solve homework, and yeah, see you after the break.